went through some Unix examples just to make sure that everybody is on the same page and have enough knowledge to understand rest of the lessons. Today, we are going to do the real HPC introduction. So today we will start with Bjørn and Maiken. They will they'll give you some motivation about why we need a cluster or a supercomputer or a HPC system. There are several terms used to refer to these things. And then we'll go on the rest of the day with more details about how to submit jobs, what is the scheduler is, and etc. etc. Yesterday, I see that you like this shared document. So we are going to use the same shared document today. The link is the same. I have pasted it on the chat. We will recurrently pasting the link for people who join later on as well. What we did is that because it's too much details from yesterday, we have archived yesterday's document with this link. So you can access yesterday's questions here if you want. And today we start a new document. The same document, but it's cleaned up. The history is backed up as well. So at the end of the course, we will archive it alongside the tutorials in the web page. So the same procedure as before. When you are not typing anything, you can have the view mode and look at it. When you want to edit something, you have to click the pencil and then edit the document. Basic markdown. So this is a shared document like Google Drive, but it's a more simpler version of it. So the questions, here's number one. You see this number starting here. So you can start the questions here. I will remove this one for now, and we will have that at the end of the day. Again, as a start, and to make sure that everybody has logged into the shared document, we'll start with the icebreaker question. This question might not be relevant for everybody, but people who see it's relevant, please go and answer. But if people see that it's not relevant for them, they can also comment on this. So the specific question is: Have you shared a computer with anybody? The question is too broad. It is not that you have a laptop you share with others. That's also, you could think of that sharing. A computer placed on a central place, a university, like a server that you had to share with your colleagues, or some remote collaboration partnership that you had to go through. This is to see whether we can have some discussion points later on. So I will let you type these things. While you do that, I'll give the screen to Bjørn. And when Bjørn starts, he can show this, show what sort of answers you have answered. And hope all of you have a good day. And by the way, very good morning to everybody as well. So let's learn some HPC. So Bjørn, you could take over the screen, please.
Yes. So can you see me now? See my screen?
Yes. So if I missed anything, you could start with that, and then you could move on. I will mute now, and I'll give the floor to Maiken and Bjørn, and see you in the next lesson.
So we'll discuss HPC. So we are here on day one. So why use a cluster? And a cluster is also named as high performance computing. That's what we do when we do use a cluster. So we'll describe what an HPC system is and identify how an HPC system could benefit you. So, but let's see in the shared document what you have written about how you share the computer with others. So it's not that easy. You can accidentally occupy the whole computer. That's known. On HPC systems, there are login nodes that are shared by everybody. And frequently, a login node is completely plugged down in with the work from one user. So many has shared computers with others. And what about you, Maiken? Have you some good histories about sharing computers with others?
Well, I've mostly had good experiences, basically, because when I started sharing computers, it was kind of via these HPC systems, and I haven't kind of had any big issues. So I've been lucky and haven't experienced lack of storage or lack of memory or anything like that.
Okay. Here, somebody shared the computer with my parents as a kid. Then a few issues came up, I think. Yeah, that's
yeah,
probably.
But this is actually a good example of permission issues. That's
Yes.
something that one can control on HPC systems also. Who has permission for what?
That's right. So, but let's have another discussion, see what you are going to use HPC for, because research problems that use computing can easily outgrow a desktop or laptop computer. So we'll write some more in the shared document about your experience with scenarios like that, or you can write what you are going to use the HPC system for. So I'll add a section for that as well. So it'll take 5 minutes to write down.
Maybe you can write it above the sessions there.
Yeah, about the sessions,
Yeah.
yes. So write what you're going to use HPC for, or if you have experienced research problems that has outgrown your laptop or desktop computer.
So a lot of bioinformatics, it looks like.
A lot of bioinformatics, yes. So I guess if you have large gene sets, it's hard to fit them into a desktop.
And climate simulation, that's also something that needs large models that are really intensive on
Yes,
memory and CPU.
image processing as well.
Yeah, so I think maybe we got enough answers here.
A lot of good answers. So let's go on. So we see that our standard laptop with not as much memory as on servers can be limiting in doing the research tasks that we want to. So so we need other resources. So here are a picture of some of the resources that's possible to use. These are servers, not necessarily HPC servers, but servers. They come in different flavors, blades, pizza boxes, or larger boxes. And they have more processing power than a laptop. The CPU can be of equal type of on a laptop, but they have much more memory and I/O capacity, input-output capacity. But these servers, they don't come with in and output devices like a laptop. So we need to access them in a different way than we do with a laptop, which has keyboard and a mouse and a screen share attached to it.
And why do we actually call them servers and not just computers or,
In
of course, not laptop.
HPC Notion, we call them compute nodes. But in cloud environments, we call them servers.
I guess it's because they kind of have a different main task compared to like a laptop, personal laptop. They serve people, you can access them remotely and you can serve them different services or access to, the underlying infrastructure like the compute nodes and so on.
Yes. So typically a server in our cloud environment has one task and one task only. And it serves mail or bank accounting. So these are then stored away in large data centers away from us and not in the office. But for the task that we are discussing with HPC, these servers are typically not enough, or they can be the HPC system Saga is configured such that you can use one server only if you want to. While this server from and Betsy, there you need to use several compute nodes to calculate or to run your simulation. So here is a picture of a HPC system. So here the boxes are equal in size, and they are connected with a local area network, or which are with high bandwidth, and so they can communicate across the all the racks. So in this way, they can work in parallel on the same task. But that said, it's not so easy. So the task has to be programmed in parallel to be shared around over the number of nodes or the cluster itself.
Yeah, so on your laptop, you might have maybe 4 cores or something like that. And then if you run a parallel program on one of these HPC clusters, you could in principle set it up so that it use like 100 or 200 cores, depending on what you're needing. So really a lot of power there.
Yeah, but on your laptop, the 4 cores will share the memory on your laptop. On a cluster, the memory is distributed, so it's not shared in the same way as on a desktop or laptop. So that's why you need to use so-called message passing, that you send messages to the different compute nodes for solving a task.
Yeah,
So,
like with OpenMPI or
yes,
other programs like that.
So it's a different program paradigm than on a desktop or these servers that are in a web cloud. So and there is no keyboard or output device connected to the clusters. So your typically interface to work for working with a cluster is the bash command interface, which we showed you yesterday. When did you start to use HPC, Maiken?
Well, I guess when I started my master's studies, but I didn't kind of know really that I was using HPC, because I was using it via this distributed computing grid, which we use in my field, which is particle physics and CERN. So I just sent a job off from my keyboard, from my terminal, into the world out there. And then it ran on some HPC resource that I didn't care about.
No,
so,
right.
Yeah.
But you got it back through the web, like
yes.
a grid.
Yes.
So you didn't use the command line interface to interact with the HPC.
No, actually, I did not. I only interacted with the grid system. So I first started using accessing directly a proper HPC when I started the work here with you all in 2016.
Mm-hmm. Right.
And what about you?
I started in 2004, then when I started to work with the HPC systems here at NTNU. So I had worked with servers for a long time, but not with clusters like we had here, like not HPC systems. So so we use the term HPC systems as a term for a standalone resource that takes computational intensive workloads. And they, as we see from the picture, they are comprised of multitude of integrated process and storage elements. Yes. So the difference between the HPC systems and cloud is that all HPC systems has all computers involved located in the same location. And all computers are connected to each other with a very fast local area network. And they are architecturally identical and runs the same operating system. On the cloud, there can be heterogeneous systems that provides a service. As we will see, the software is installed and accessible from all computers, and there also is a shared storage that all the compute nodes can access. And there is a batch system, a scheduler, which runs the jobs that runs on the HPC system. So that's a brief and short introduction to HPC.
Yeah, and I wanted to mention that, like, for an HPC system, the difference also between the HPC and cloud is that in some way, as you mentioned, all the software and everything is set up for you. On the cloud system, typically you kind of start up some virtual machines, and you have to kind of set up the virtual network yourself. You have to install the software yourself. You have to choose from, you know, what you want on it. So
that's right.
It's it can do the same task, but it requires much more of your customization, while an HPC is kind of there, ready, fast working, and yeah.
And you can't configure it.
Yeah, you can't configure it yourself. Yeah.
No.
So it's a different use case.
Different use case. That's right. So that can be limiting for some users, that they're not able to configure it with their software and the way they want to use it. Okay. So then it's over to working on a remote HPC system. I think it's time for Sabri.
Yes, thank you, Bjørn. I'll take the screen.